Good afternoon, students. Welcome back once again to the mathematics class. So, in this lecture, we are going to study mutually exclusive event addition rule, right? Rules of probability are there here. So, let's see first rule before going to start that event. So, first we'll see rules of probability. What it says rules of a probability after assigning the probabilities to each of the simple events in the sample space. We shall study the following rules of a probability, keeping in mind that the algebra of an event and also the definitions of mutually exclusive or exhaustive events or both are already discussed in the previous lecture. So now in this lecture we are going to study an event A and its complementary event A bar. Let's see first one, an event A and its complementary event A bar, right? So let's say rule 1 under this. First rule, what it says, let's see. If P is a probability, if P is a probability of the event A and Q the probability of its complement A bar, then Q equals to 1 minus P, or we can write P of A bar equals to 1 minus of PA. So proof also we have for this one. So let's see proof for this one also. Let S be the sample space of random experiment, already you know. And A be an event of S. Event of S. Then A bar is complement event of A, because A union A bar is sample space S and A intersection A bar, which is equals to 5. It is empty set. So now therefore P of A union A bar, which is equals to P of S, so which implies P of A plus P of A bar, which is equals to 1 by axiom 3 and 2. By using the axiom, what we are doing here, P of A union A bar equals to P of S. So P of A union A bar can be written as P of A plus P of A bar, which is equals to 1. So again, which is equals to P of A bar, which is equals to 1 minus P of A. So finally what we have, Q, which is equals to 1 minus P, where P of A bar is taken as Q and P of A as P, right? It is nothing but an event A and its complementary element event A bar. Got it? Let's see, for example, for example, for example, a person write 6 letters and addresses 6 envelopes and gives them to his illiterate servant to post. What is probability that the servant puts the letter into wrong envelope? Wrong envelopes. Let's see. What says, a person write 6 letters and addresses 6 envelopes and gives them to his illiterate servant to post. What is the probability that the servant puts the letter into the wrong envelopes? They are asking probability of wrong envelopes. So let's see, there are 6 letters, right? Totally what we have, there are 6 letters and 6 address envelopes. There are 6 letters and 6 address and envelopes, right? These are the envelopes, right? Then the number of all possible cases in which the 6 letter can be put in 6 envelopes is, we can write 6 factorial or 70, right? Which is the number of possible cases. Since the servant is illiterate, there is every possibility of putting the letter into the wrong addressed envelope. So there is only one way or a case of putting the letter into correct addressed envelopes. Let us call this event as A. It is event A, then P, which is equals to P of A, which is equals to 1 upon 720. So now A bar, the complement of A, the complement of A is the event that the letters and envelopes are not put correctly. So hence we have Q equals to P of A bar, which is equals to 1 minus P. It is 1 minus 1 by 720, which is equals to 719 by 720. So which is nothing but our example of rule of probability in that event of A and its complementary event A bar, right? So with this we'll conclude our today's lecture. In the next lecture we will discuss mutually exclusive event addition rule. Mutually exclusive events addition rule, right? So till then, take care, stay at home, stay safe. Thank you.